Okay, so our next section is testing claims about a population proportion. So far we've tested claims about the mean of a population. Today we look at testing claims about a population proportion. The process is very much the same. However, before we start, we have two conditions that must be met before we can proceed. First of all, sample has to be obtained by simple random sampling. And secondly, n times p times 1 minus p has to be greater than or equal to 10, with n less than or equal to 5%, 0.05 of big N. So in other words, the sample size cannot be more than 5% of the population. Now again, that's a guesstimate. It doesn't have to be exact, so don't worry about actually doing the calculation. But the n times p times 1 minus p has to be greater than or equal to 10. That one has to be there. So here it is. Going through the classical method first, testing a claim regarding a population proportion. Claim is made. Claim is used to determine the null and alternative hypothesis. Okay. Select a level of significance, alpha, depending on the seriousness of making a type 1 error. Compute the statistic. Oh, we're back to p hat. All right, so p hat, remember, p hat is x over n, where x is the number of positive things that happen and n is the number of things we collected, number of data points. So we use table 4, that's the z table again, and we compare the critical value to the test statistic and state the conclusion. Here we go. Let's try it. So to test, p is 0.3 versus p is greater than 0.3. A simple random sample of size 200 is obtained from a population that is known to be normally distributed. If x is 75, compute the test statistic. Okay, so the first thing we have to do is we have to find p hat. P hat is x over n. So in our case, that's 75 over 200. If I do that math, 75 divided by 200, I get 0.375. I'm going to keep that, and I'm going to go to my z formula, or my z formula, which is p hat minus p over p times 1 minus p over n, and I take the square root of it. So if I do the math, 0.375 minus 0.3 divided by the square root of 0.3 times 0.7 over n, which is 200. So 0.3 times 0.7 equals, divided by 200 equals, I want the square root of that. Okay, so I'm going to do 0.375 minus 0.3, and I'm going to put parentheses around that. Divided by the square root of my previous answer, I have 2.31 as my test statistic. If the researcher decides to test the hypothesis as the alpha is 0.05 level of significance, what are the critical values? Okay, I'm going to go ahead and draw down here because it makes more sense to me. All right, if I have 0.05 and I'm on the right, so this is 0.05 on the right, so that means I need 0.95 over here. I grab my table, or I look up in my little cheat sheet there. I need 0.95, oops, going the wrong way. Looks like 1.645. And it's on the right, so 1.645 is my critical value. So here's my line. I'm at 2.31, so I'm somewhere over here. Do I reject or do I fail to reject? In this case, I'm in the region, so I would reject the null hypothesis. And once again, the process is the same as it was before, so this is not new. I'm just reviewing it with you. All right, let's take a look at how we can do this on our calculator. So we have this question. I'm going to zoom out here a second. There we go. The drug Lipitor is meant to reduce total cholesterol, LDL cholesterol. In clinical trials, 19 out of 863 patients taking 10 milligrams of Lipitor daily complained of flu-like symptoms. Suppose that it is known that 1.9% of patients taking competing drugs complain of flu-like symptoms. Is there sufficient evidence to support the claim that more than 1.9% of Lipitor users experience flu-like symptoms as a side effect at the alpha is 0.01 level of significance? All right, so we need to pull out our numbers here. Let's see. We know X is 19. We know N is 863. We know P is I'm going to do 0.019, 1.9%. My claim, just gathering all my information, is that P is more than, so greater than 0.019, again 1.9%. What else do I need here? Oh, I need alpha. Alpha is 0.01. All right, I think, okay, so that makes H sub O, P equal 0.019, H sub 1, P greater than 0.019. Okay, and again, I did that so that I know which way I'm going to use my arrow. All right, so I grab my calculator, and this time we're going to go to Stat, and we're going to go to Tests, and the test we're going to use in this case is the 1 prop Z, so sample 1 prop Z, which is number 5. So test number 5. And we hit enter. And we enter the information that we have. We know that X is, P, 0.019. We know X is 19. We know N is 863. We want a right-tailed test, so make sure it's pointing to the right, and we're going to calculate. It tells me my p-value is 0.258. I'm going to compare 0.258 to 0.019. It's obviously greater, therefore I'm going to fail to reject. Which means what? There's not sufficient evidence to support the claim that more Lipitor users, or that Lipitor, yeah, more Lipitor users flu-like symptoms. Okay, finish writing that and slide that up for you. So there's not sufficient evidence, so we fail to reject. So we're not accepting the claim. Support the claim that the Lipitor users experience more flu-like symptoms. So far, so good. All right, let's take a look at another one. Okay. In 1995, 40% of adults aged 18 years or older reported they had a great deal of confidence in public schools. On June 1st of 2005, the Gallup organization released results of a poll in which 372 out of 1,004 adults aged 18 and older stated they had a great deal of confidence in public schools. Is there evidence that the alpha is 0.05 level of significance to conclude that the proportion of adults aged 18 or older having a great deal of confidence in the public schools is significantly lower in 2005 than in 1995? Okay, what do we know? Well, let's see. We know X is 372. We know N is 1,004. We know P is 0.4. we know alpha is 0.05. We have a claim, okay, is significantly lower, so P less than 0.4. So H sub O, P equals 0.4, H sub 1, P less than 0.4. This is a left-tailed test. I think those are all the numbers I need. So let's go to our calculator. I think I can do this. Okay, stat, tests, 1 prop Z. Oops, 1 prop Z, number 5. Okay. My P is 0.4. My X is 372. My N is 1004. It's a left-tailed test. I highlight the left. I hit calculate. And it tells me my p-value is 0.028. And I compare 0.028 and 0.05. It's definitely less. Therefore, I reject. I cannot spell this morning. H sub O. If I reject H sub O, that means there is sufficient evidence to support the claim that there, let's do the confidence level. Let's do there. There are fewer people confident in public schools in 2005. That's a good way to say it. Again, creative license here, not a huge deal. All right. Okay, notice we're not doing any with data because there really isn't any way to do this with data. Our data is right here. We have X and we have N. All right, I have one more. 1997, 4% of mothers smoked more than 21 cigarettes during their pregnancy. An obstetrician believes the percentage of mothers who smoke 21 cigarettes or more is less than 4%. So claim P less than 0.04. She randomly selects 120, so N is 120, and finds that 3 of them, X equals 3, smoke 21 or more cigarettes. We have alpha is 0.05, and we have H sub O, P equals 0.04, and H sub 1, P is less than 0.04. Again, we are ready to go. So stat, tests, 1 prop Z, fill in the information, 0.04, X is 3, N is 120. It is a left-tailed test. Oops, left-tailed. And we calculate. It gives me a p-value of 0.201. And I'm comparing 0.201 to 0.04. Well, this is obviously larger, so we failed to reject, which means there's not sufficient evidence to support the claim that the percentage of smoking mothers smoking 21 cigarettes is lower. Okay, and that is how we do p-hat.